Clay-Bob pendulum. A 0.020 kilogram piece of clay moving at a speed of 5 meters per second strikes a 0.50 kilogram pendulum bob at rest. Here's the bob, here's the clay. The length of the string is 0.80 meters and the pendulum bob is a height h 0.70 meters above the floor at its lowest point. After the collision, the clay sticks to the bob and the system oscillates as a simple pendulum. A. What is the speed of the clay bob system after the collision? B. What is the maximum angular displacement of the pendulum? And C. What is the period of the clay bob oscillating system? Continuing the problem, what is the total energy of the oscillating system? And E. The pendulum bob makes one complete oscillation, goes like this and comes back, but the string breaks at the lowest point. How far is the bob from its original rest position when it strikes the floor? Part A. What is the speed of the clay bob system after the collision? Use the conservation of momentum at the impact point, as there are no external net forces acting on the clay bob system. Kinetic energy is not conserved, as this is an inelastic collision. So we have mv equals m, which is the mass of the clay, and large M is the mass of the bob, times the velocity of the clay bob system. Rearrange to solve for velocity, substitute in our variables, and we get 1.99 times 10 to the minus 2 meters per second. Keep an extra significant figure in the answer, as this is an intermediate result. What is the maximum angular displacement of the pendulum? At the maximum angular displacement, the bob will be at its maximum height, where its velocity will be 0. The conservation of energy is used, and the kinetic energy at the impact point will all be converted into GPE at the maximum height. The maximum height h is found, but the question is asking for the angular displacement, so a little geometry and trigonometry is required. Sketch a right triangle with a hypotenuse, over here, equal to the length of the string L. Capital H is the height of the bob above the ground when at rest. Lowercase h is the maximum height that the bob reaches above its rest point. The base of the triangle is a horizontal distance from the bob at its lowest point to its highest point. The height of the right triangle is L cosine theta, over here, where theta is the maximum angular displacement of the bob. The maximum height, lowercase h, which will be used to calculate the final GPE, is L, right, that's this whole piece here, minus L cosine theta. For this part of the problem, set the GPE at the initial height of the bob to be 0. All we really need is a difference in GPE between where the bob starts and how high it rises. Time for some algebra. Set the initial kinetic energy equal to the final gravitational potential energy, since the final kinetic energy is 0. So here's our kinetic energy. Here's the GPE at the top. And you have to use both masses, but it's not such a big deal here because why? They just cancel out. So we're left with this, and then we substitute in for h, L minus L cosine theta. Then we switch the sides around, divide through by g. Then we divide both sides by L. And finally we get this expression. We're now ready to substitute in our givens. And we find out the theta is 0.40 degrees. What is the period of our system? Well, we'll use the equation for the period of the oscillating system in simple harmonic motion, which is 2 pi times the square root of L over g. Substitute in our numbers, and we get 1.8 seconds. D. What is the total energy of the oscillating system? The kinetic energy of the oscillating system is less than the kinetic energy of the clay before it struck the bob, as much of the clay's kinetic energy was transformed into heat and deformation of the clay. Remember, it was an inelastic collision. So we're going to use the clay bob velocity, not the velocity of just the clay, and the height h above the ground for GPE. We're going to need that for part A. So here's our total energy. kinetic energy max, which is right here, plus the GPE of the clay bob at that point. So we have 1/2 m plus m v squared, where this is the velocity of the clay and the bob. Here's the mass again, times GH. We factor out the m plus m to make the math a little easier, substitute in our numbers, and we find we have a total energy of 3.5 joules. Nearly all of the energy is in the GPE above the ground. This is now a projectile motion problem as the bob moves tangent at its lowest point of the oscillation's arc in the horizontal direction. The object has a horizontal velocity of 0.0199 meters per second, 0 vertical velocity, and a height of 0.70 meters above the ground. Solve for the time to fall with the second kinematics equation in the y direction. Then find the range by using the second kinematics equation in the x direction. Calculate the time to fall. So we use second kinematics in the y direction. This goes out right away because there's no velocity in the y direction. And we substitute in negative g for the acceleration. Then we arrange it to solve for t. Substitute in our variables. 0 is the final height. This is the initial height. And we get the time to fall is 0.374 seconds. The range, which is the distance from the original rest position, so over here, and we're looking for this quantity right there. Second kinematics in x, we have no acceleration in the x direction. Gravity just works downwards. Here's our values. Here's the equation. Substitute in. The initial position we'll say is 0. Here's the velocity, and here's the time to fall, and we get 7.4 times 10 to the minus 3 meters.